Now we're on question 4, and question 4 says, given g of x is equal to 1 over x minus 1 plus 2. So we have to write down the equations of the asymptotes of g. Okay, so it's only for 2 marks. The asymptotes of g, you have a vertical asymptote and a horizontal asymptote. Now, how you know which one it is this, the vertical asymptote is always the one with x. So if you have an x minus 1, your vertical asymptotes equation is actually going to be, you can kind of see it like you're saying x minus 1 is equal to 0, and then you're taking that 1 over. So it's x is equal to 1. That's the vertical asymptote. And then the horizontal asymptote would be the number that appears here, which is the number for q, right? So this one is p. Now, this one, it is horizontal, so it's going to start with y. Y is equal to 2, and that is our answer there. Moving on to the next question. 4.2 says, draw the graph or a graph of g indicating any intercepts with the axes and the asymptotes. So we already have the asymptotes. To draw the graph, we just need our intercepts. So let's go ahead and find those. So our equation is g of x is equal to 1 over x minus 1 plus 2. So first of all, we can go ahead and find our x-intercept. To find the x-intercept, you just have to make y equal to 0. So our y is our g of x, of course. So we say 0 is equal to 1 over x minus 1 plus 2. And then to solve for this, you can go ahead and take the 2 over, and it becomes a negative 2 is equal to 1 over x minus 1. So you have a number, fraction, and an equal to sign. Just turn the number into a fraction by putting it over 1, and then cross multiply. So we're going to say the 1 times 1 just gives us a 1. And then we're going to say the negative 2 times x minus 1. But remember, it's 1 term times 2 terms, so it has to multiply to both of them. Okay, like that. So I'm going to go ahead and do that straight away from here. I'm saying the negative 2 multiplies to the x and gives you a negative 2x. And negative 2 times negative 1 gives you positive 2. Then because negative 2x is negative, I'll take it over and make it positive 2x. Then we still have a 2 here. And this one comes over and becomes a minus 1. Then 2x is equal to 1. And then divide both sides by 2. And therefore x is equal to a half. So that is your x-intercept. And as a coordinate, it is a half and the y value is 0. Because remember, we say make y equal to 0. So that's x-intercept. Then we need to find the y-intercept as well. So the y-intercept we find by making x equal to 0. Okay. And so making x equal to 0, that is g of, in place of x, I say 0, is equal to 1 over, in place of x, 0 minus 1 plus 2. Then let's simplify that. That is g of 0 is equal to, well, 0 minus 1 is negative 1. So 1 over negative 1 is already negative 1 plus 2. That's going to give you positive 1 because it's 2 minus 1. So as a coordinate, our y-intercept is 0 and 1. So there we have our intercepts. And now we can draw our graph. With the graph, it's quite simple. Just draw a Cartesian plane first. And then make sure to label your axes. So that is our x-axis and that is our y-axis. Okay, so now that we have that done, you can go ahead and start plotting. If you want, you can put coordinates. So I'll just put a few coordinates. It's not really that necessary though. Okay, so this is the graph. And then we just have to put down, first of all, before the coordinates, put down your asymptotes. It's very important that you do that first. So remember that our asymptotes are x is equal to 1 and y is equal to 2. The x is equal to 1 is your vertical asymptote, and this one is your horizontal asymptote. So x is equal to 1, it's a vertical line, meaning it stands up. So it's going to be a vertical dotted line, of course, that will pass 1. So like that, and then just make sure to label it. So it's x is equal to 1. And then our horizontal asymptote of y is equal to 2 is a horizontal line that will pass 2. And then remember to label it y is equal to 2. Okay, so now that we have our asymptotes down, we can go ahead and start putting down our coordinates. So remember the first coordinate we have is our x-intercept, which is a half and 0. So it's on the x-axis, it's a half and 0, meaning it is not past 1, it's here. So I'll put that there, and then I'm going to say a half because, we don't have that coordinate there. So you don't have to say a half and 0 because it's on the x-axis. You can just write a half. But when it's like a point, maybe something like 3 and -2, then you have to actually write it down. Okay, then we have that. And then the next point that we have is our y-intercept, which is 0 and 1. So we'll just go 0 and 1. And so we can see that that goes over there. Again, I don't have to write the coordinate. Okay, there's one more thing that we need to consider now. Now that we have our intercepts, we have our asymptotes, we need to consider the shape of this graph. So the hyperbola, the general form of it is y is equal to a over x minus p plus q. You see the value of a? If a is positive, then your graph is going to lie in the first and the third quadrant. And if a is negative, then your graph is going to lie in the second and the fourth quadrant. Okay, so that's how it works. So as you can see, our a value is 1, and that's positive. So it's going to lie in the first and the third quadrant. So our graph is going to look like this. When we're sketching down our graph, we know that it lies here and here. And so let's just follow the shape that we have here. Since our graph is going to lie here as well, you see that it's going to go like this and pass that and then go down like that. So something like this, it passes like that. And then we're going to have the other wing, which is going to be here in the first quadrant. So that you can just copy the way the shape looks, and you can just go ahead and say that is your other wing. So I'll just leave it like that. If you like, you can go ahead and find another point on the graph. That would also be helpful, but it's fine like that because the most important points are there and the shape is there. Okay, so that is our graph. Moving on to the next question. Then question 4.3 says, determine the values of x where g of x is greater than 0. Okay, so where is g of x greater than 0? Okay, so to do that, we need the graph. We're going to look at the graph and we're looking for, remember, g of x really just stands for y, meaning where the y values of g going to be greater than 0. The y values, okay, should let you think about the y-axis. Where you're thinking about y values that are greater than 0, these would be y values greater than 0, meaning you can only consider parts of the graph that have y values here. In other words, y values that are above the x-axis, because everything below the x-axis has a y value smaller than 0. So we're only going to consider parts of the graph that are above there. So as you can see, there is this part of the graph that we have to consider and also this part of the graph. So all we have to do is now tell them the values of x for which these parts of this graph exist on this Cartesian plane. So we're going to look at that, and we can look at this and line it down to the x-axis. You see, if you line it down to the x-axis, you see the values that you have. It starts off here at a half, okay? That's when it becomes above the x-axis. And so these are values that are moving towards this direction, which are values that are really smaller than a half. So for that, we can actually tell them that x is less than a half. Now, I don't have to say less than or equal to here because they only ask for where g of x is greater than 0, not equal to 0. At a half, g of x is equal to 0 because it has a y value of 0 there. Okay, so for that wing, we're done. Then we have to deal with this wing. So what are the values of x for this one? Well, do you see that this graph is going up there and it's going to get closer and closer to this asymptote? So if you look at what's going on, these are the x values we're actually speaking about. So we can see where it's heading towards. It's heading towards the right-hand side. But where did it start? It started here after this asymptote of 1. Okay, that x value of 1. Then it was every value that came after it to the right. So this is where x is greater than 1. Okay, so we can tell them that. So or x is greater than 1. And that would be our answer for this question. There's nothing really. We cannot say x is equal to 1 because we have an asymptote there and the graph does not have a value at x is equal to 1. So moving on to the next question. The next question says, determine the equation of the axis of symmetry of G which has a negative gradient. Okay, they've been very nice in these questions, honestly speaking. So the whole question 4 was really good. Axis of symmetry, we have to think about it like this. Okay, so you see a hyperbola. If you have a hyperbola, whether it is the one with a positive a value or negative a value does not matter. It will have two axes of symmetry. It first has the positive one, and the equation of that you just need to remember. If you remember the equation of the general equation of your hyperbola, which is y is equal to a over x minus p plus q, then you will remember this equation. It's just y is equal to x minus p plus q. See? Like in that original equation. So that's the positive one. That's the one with a positive gradient. That's why x is positive. The one with a negative gradient, if you can remember this one, you remember this one. The one with a negative gradient is formed by just putting a negative in front of x minus p. So y is equal to negative bracket x minus p and then plus q. Then if you distribute that, you see that y is equal to negative x plus p plus q. So that is the equation of the axis of symmetry of G, or of a hyperbola with a negative gradient. So let's go ahead and fill this in. So y is equal to negative x. And what is p and q? Well, we knew those values already from our asymptotes. You see that this is p here and this is q. Meaning, you see it says x minus p, x minus 1. So p is 1 and q is 2. Just like in your vertical and horizontal asymptotes. So we're just going to say we have plus 1, which is p, and plus 2. So your equation is just y is equal to negative x plus 3. That is the equation of that axis of symmetry. Okay, and that is it for question 4. And then we move on to question 5. Question 5 says, in the diagram, the graph of f of x is equal to log of x with a base of a, and g are drawn. Graph G is a reflection of f in the line y is equal to x. Okay, so we have the log graph of it, then we have the exponential graph of that. And so because they said it's a reflection, it's really just the inverse of that graph. Okay, then they tell us that graph f passes through the points P, which is 4 and 2, and Q is the x-intercept of f, and R is the y-intercept of G. Okay, so they're just naming points that we have there. The first question, 5.1, says, write the coordinates of P prime, the image of P on G. Okay, so that's just the image of P on G. Remember that this is a reflection of this through that line y is equal to x. So it's the inverse of it. Since it's the inverse of it, when you're looking at this graph and looking at that graph, what changed is all they did was they swapped the x and y values. Okay, so to find the image of P on this graph, you would just swap your x and y values because it's the inverse. That's what happens with inverse functions. So P prime would actually be 2 and 4, and that will be your coordinate that you have here. So P prime is 2 and 4. Okay, moving on to the next question. Question 5.2 says, show that A is equal to 2. So let's look at that. Let's find A. So where did they mention A? They mention it in f of x. So f of x is equal to log, and we have x with the base of A. So let's go ahead and write that. So since we know f of x is log, we have A as a base. How do we find out that A is equal to 2? Well, this equation is almost complete. The only thing missing is the A. So it means that we just need one point to be able to find it. So be careful. Make sure you take a point that lies on F. So let's look at the graph. On F, we have a point P, which is 4 and 2. So let's go ahead and substitute 4 and 2 into this equation. So the y value is 2 is equal to, we have log, our base is still A, and the x value is now going to be 4. Okay, so now that it's in this format, we can actually put it back in exponential format so that we can solve for this, because we can't actually use the calculator for this since this is A. So this is how to put it in its proper format. First of all, you can think about what the base is. Remember, I kept calling this base. Okay, base A. So that is your base. Your base is that number there. We're going to say that is A. But now A is being raised to the power of what? A is raised to the power of whatever this log function was equal to. Okay, so that's how that works. The logarithm graph really just makes the exponent, the subject. So it's a to the power of 2 and then is equal to the number that the exponential function should be equal to. The exponential expression is 4. Okay, so that's how it works. That's your base, that's your exponent, and then that's the number it is equal to. Okay, now when we look at this, this is actually a quadratic equation because it has a squared. So naturally you would think, oh, okay, we can just square root both sides, which is true. You can do that. And I know normally we would consider the plus or minus, but please note we are speaking about exponential functions here. In exponential functions, we don't have negative bases. And I know that sounds weird. It's like, why don't we have negative bases? But we don't. And the reason why is because if you have a negative base, okay, let's say you have something like negative 2 to the power of, let's just try two numbers quickly. Negative 2 to the power of 1. And let's try negative 2 to the power of 2. And then you see what's going to happen. Let's also just include a third one. Negative 2 to the power of 3. Negative 2 to the power of 1 is negative 2. Negative 2 to the power of 2 is positive 4. Negative 2 to the power of 3 is negative 8. You see what's going on here? This is not going to draw an exponential function. It's going to be a zigzag function. Okay, so you're going to have like negative 2, 4, negative 8, and then something else. It's going to be a zigzag function. And that's why in exponential functions, the base is never negative. Okay, so that was just a little something I just wanted to throw in. So we're already just going to tell them that a is just equal to positive 2. And there we go. And that's our answer. Okay, moving on to the next question. Okay, 5.3 says, write down the equation of g in the form of y is equal to. Okay, so the equation of g. Remember they told you that this is f, the log, and then g is the exponential. So they want you to write down the equation of g. So since it's in the form of y is equal to, well, either ways, we would start with y is equal to, and let's just get our log function, the only one they gave us. They only gave us this. We're going to work with this and get it to g. It's inverse. So that is log, and we have the value of a now, it's 2 and x. So step 1, in order to find g, which is the inverse of f, you're going to swap your x and y values. Meaning in place of y, I'm just going to replace that with x. And then I say log base 2. And in place of x, I replace that with y. Okay, so now at this point, we have to make y the subject. So those are the only two steps. Swap x and y, make y the subject. That's all. Now, the only way to put y as your subject is to put this back in exponential form. Okay, so I'm going to go ahead and look at where my base is. My base is 2. So 2 is my base. And remember what the exponent is supposed to be? The number it's equal to, because the log graph always makes the exponent your subject. So we have x there. And then what is it equal to? It's equal to the y. And there we go. That is our equation of g in the form of y is equal to. Moving on to the next question. Then 5.4, we have t is a point on f in the first quadrant where TR is parallel to the x-axis. And we need to calculate the area of triangle RTP prime. Okay, that's specifically P prime. Okay, let's get the graph down and see what they're talking about. Okay, let's start off with what they told us at first. They first said T is a point on F in the first quadrant where TR is parallel to the x-axis. So there's this point T, and it's going to lie on the graph of F. But also, they also told us that TR must be parallel to the x-axis. So when you join T and R, they will be parallel to the x-axis. Lines that are parallel to the x-axis are horizontal lines. So it means that to draw that line or that point, you could really just do this. It's going to be a line. And so because this line is parallel to the x-axis, T is going to lie here on that line. Okay, that line does not look very, let me just fix that. Okay, so it's going to lie on here, and that is our T. So TR is parallel to the x-axis. Then what else do they say? Okay, so then they also tell us, they ask us to calculate the area of triangle RTP prime. So remember that P prime was somewhere here, but I'm starting to see that it's probably going to be here. It depends. It really just depends at the end of the day on where this is. Now, I could estimate where P prime is, I'll just put it here so long. And the reason I'm now thinking about it is because if I put it like too close, it's going to change the shape of this triangle. And if I put it too far, it's also going to change the shape. So I'm going to just put it anywhere for now. P prime, let's just say that was here. And remember, it was just 2 and 4. We will figure out where exactly it is, because remember, these are not drawn to scale. So just because something maybe looks like a right angle triangle, it doesn't necessarily mean it is one, unless they show you, some indication that, yeah, we have a right angle. Okay, so let's figure out how to actually draw this. Since we have this line already, and we know it's supposed to form a triangle eventually with that point, let's think about what T is going to be. Now, right now we don't have any other information about T other than the fact that this is parallel to the x-axis. However, if this is parallel to the x-axis, it means it's a perfectly flat line. So it would mean that the y value of r and the y value of t are the exact same thing. See? Because whatever number is here, that y value is also going to be the y value of your coordinate t. So the first thing would be, let's find r. Now in this case, r is easy to find because your equation is just y is equal to 2 to the power of x. Nothing has been added here. It's not plus 3 or anything. It hasn't been shifted to the left or right. Additionally, we can also see that the asymptote, because the exponential function, we're supposed to have a plus q here. Because there's nothing here, it means that your asymptote is 0. So here's the thing. If you have an asymptote of 0, and we have not added anything to the x, by default, it would mean that the first intercept, the y-intercept, is going to be 1. That's something that you're going to notice with these graphs all the time. You can calculate it if you want, but it's going to be 1. So now we know that r is 0 and 1. And so that would mean that t, its coordinate, is something and 1. Okay, so we know the y value now. Since we know the y value, we can actually find the x value, because this t lies on the graph of f. And because it lies on the graph of f, we can substitute this y value of 1 to get our x value. So let's go ahead and do that. So we take the graph of f, which, if you remember, is this with the 2 there. Okay, so this is our graph of f. And we are going to go ahead and substitute the y value of 1 to find our x value. So our y value is 1, which is equal to log, and we have a base of 2, and we have x. Now to solve for x, you have to put it in exponential formats because the calculator cannot do this for you. So we're going to go ahead and say our base is 2. And then our exponent is whatever number that is, which is 1. Which is equal to x. And so now we can see x actually is equal to 2. So I didn't want to make assumptions. That's the whole thing. So we know the coordinate of t now. The coordinate of t is actually 2 and 1, which is great. And the reason I said this is great is because now you see that this is 2. The x coordinate is 2. Do you see another point with an x coordinate of 2? That will be P. So now I know exactly where P is. P is actually just perfectly in line vertically with T. So it's 2 there. Okay, so that's 2 and 4. That's what we have there. And now if you join this triangle, you actually get a what type of triangle there? You're going to get a right angle triangle. And that is a right angle triangle because you can see that they have the same x value, so they're perfectly in line. This is a vertical line, really. And this line is parallel to the x-axis, making it a horizontal line. Therefore, you have a right angle. Okay, because we have a right angle triangle, we just have to now find the area of this triangle. They asked us to find the area, and we can use the rule 1/2 times the base times the height. That's what we can use. So I'm saying the area of triangle RTP prime is equal to 1/2 times our base times our height. So we just have to find the base and the height. The height is going to be super easy to find, and also the base, because this is a flat line. So we don't need to use any distance formula. Here's the reason I say so. You see that the base, this line is going from, the x value is 0, and it's going from this point 0 all the way to 2. So how long is the base? It is 2 units, literally 2 units, 0 to 2. That's it. And then the y, we can also find that easily by saying, since this is a vertical line, and this y value is 4, and this y value is 1, then just say the difference would be your height, meaning just say 4 minus 1, and that gives you that distance over there, and that's going to be 3 units. So there, our base is 2, our height is 3. Okay, remember this is not Euclid, so you don't need reasons. So we're saying a half multiplied by our base of 2 multiplied by our height of 3. And I'm just going to go ahead and say 2 times 3 is 6, and then half times 6 is 3. So our area is 3 units squared. Okay, remember that is the measurement of area. So that is our answer for that question. And that is the last question in question 5. So we finally move on to question 6. Okay, so now we are finally on question 6. And question 6 says, the graphs of f of x is equal to x squared minus 2x minus 3, and g of x is equal to mx plus c, are drawn below. Then we have d and e are the x-intercepts, and p is the y-intercept of f. Okay, so x-intercept, y-intercept. Then they tell us that the turning point of f is t, which is 1 and negative 4. Okay, they already gave us that coordinate, so just put that down. 1 and negative 4 is already there. Then they tell us that the graphs of f and g intersect at p and e. So graph of g and f here. So those are the points of intersection of those two graphs. The first question is, you need to write down the range of f. So remember, the range is really just all the possible y values of a graph. So if you see the way your graph looks, it's a parabola, and your y values, when we're looking at all the possible y values it can have. So look at this parabola. It has a y value here, for example, and here, and here. Okay, even these points have y values over here and here, and they keep having y values, and then the graph shoots up, meaning it's going to keep having all of these y values. But can you see a place where this graph will never have y values? That would be here. See below there, there is no more graph there. So there will be no y values there. So for you to tell the y values, or the range really, of a parabola, this concave parabola, you're going to actually look at where the y values started. What was the lowest y value it had? And that would be this y value here, negative 4. That's where it all started. Then it started having every other y value above it. So your range is going to be y is greater than or equal to negative 4. Now it has to be equal to negative 4. Do you see that? At negative 4, you have a physical y value, okay? The graph has a point that includes negative 4, and that's why our range is that. Okay, so that is our range. Moving on to the next question. Okay, so 6.2 says calculate the coordinates of D and E. So remember, they told us that D and E are our x-intercepts of this graph. Since we already have the equation, we can find the x-intercepts of them. Okay, let's go. So this is the equation we have, and these are x-intercepts, so you just have to make y equal to 0. So we have x squared minus 2x minus 3. Then this is a trinomial. Open up two brackets. Say x multiplied by x gives you the x squared. And then we need factors of negative 3 that can give us negative 2. Well, 3 is a prime number, so we can only have 3 and 1. So since this is negative, 1 has to be positive, 1 has to be negative. Which ones should it be so that we can have negative 2 in the middle? Well, we could make the 3 negative and the 1 positive. So negative 3 plus 1 gives you negative 2. So our factors are just negative 3 and positive 1. Then solve for x. It would mean that x is equal to, take your negative 3 over the equal to sign, 3, or x is equal to, do the same thing there, negative 1. Now just assign it to the correct one. D and E, they want the coordinates of D and E. So when we look at D, D is lower than E. So it's going to be the smaller one. So that is, D is going to be the -1 and 0. That's your y value. And then E is 3 and 0. Okay, so that is that question. Moving on to the next question. In the next question, 6.3, they want us to determine the equation of G. Okay, so let's find the equation of G. When we're looking at the equation of G, do you see that G only has 2 points? So it has this over here. Remember, this is not, that's not that number there. And it has E over here. We know what E is already, that E is 3 and 0. So we can say 3 and 0. But what is this point over here? Well, first of all, it lies on the y-axis. And do you see that it is one of the points of intersection of F and G? Since it lies on the y-axis, it would mean that it's the y-intercept of both graphs. But the good thing here is that we have the graph of F. So it's the y-intercept of F. So to find that, you don't have to go and make x equal to 0. It's already showing here, since this is in standard form. It's in the form of ax squared plus bx plus c. And c stands for your y-intercept. So we know that our y-intercept is -3. So as a coordinate, that is going to be, it's a y-intercept, meaning x is equal to 0. That is 0 and -3. So there we go. We got 2 points on this graph, so we can actually find the equation of G. So let me put down these points. Okay, so these are our coordinates. We have our 0 and -3 and our 3 and 0. To find the equation of G, since it's a straight line, the equation of a straight line is y is equal to mx plus c, meaning you first need to find the gradient of this line. So the gradient is found by saying y2 minus y1 over x2 minus x1. And so this is equal to, and I put it in a top-down arrangement for a reason, so that we can just say y2 minus y1. Even if this is not y2, it's fine. Just stay consistent as well. If you say -3 minus 0, say 0 minus 3 as well. So -3 minus 0 over 0 minus 3. Okay, and so that's going to give us on top, you see you will have a -3 still, and 0 minus 3 is -3. So our gradient is 1. Okay, so we have our gradient. Now we just have to find C. So there are 2 ways. You can substitute it into this and then find C. Or you could use this formula. So I like to use this formula. It is y minus y1 is equal to m bracket x minus x1. So the y1 and the x1 just stand for a coordinate that you're going to substitute in. I'm going to choose the point E because it looks easier to use. So that's going to be my x1 and that's my y1. So I'm going to substitute by saying y minus my y1 is 0 is equal to, I have my gradient, it's 1. And then multiply by x minus my x1 is 3. So we're going to put that there. So it's 3. And we just have to simplify now. Now y minus 0 is just y. And then you have 1 here being multiplied. So if you FOIL in, it's x and minus 3. And that is your equation. So they say determine the equation of G. So we just have to write it as G of x. So G of x is equal to x minus 3. And that is our answer. Moving on to the next question. The next question, 6.4, says, write down the values of x for which f of x minus g of x is greater than 0. Okay, they're just trying to trick you by saying minus. You don't have to subtract anything. All you have to do is this. You see, since it says f of x minus g of x is greater than 0, why don't you just take negative g of x over the inequality? So you're going to have f of x and then greater than, and that now comes over and becomes positive g of x. This is actually what they're asking you. They're asking you for the values of x for which f of x is going to be greater than g of x. So remember they refer to y values, right? So because we're speaking about y values, if we're looking for places where f is greater than g, the only places where f is going to be greater than g is where the y values of f are higher than the y values of g. Okay, so you're really looking for places on the graph where the graph of f is above the graph of g. Remember, you can use a vertical line. Okay, a vertical line, very helpful. You carry it around with you. It's like a ruler. So in an exam setting, you just use a ruler. So I'm going to look through and see the places where F is above G. So here, is F above G? Yes, it's above G here. Is it above G here? Yes, see? There, this is on top of that. It's above that. And then if you keep going, you'll see that where they now meet at the same point would be at this point. And then after you get here, now you see there's an issue here. G is now above F and we don't want that. So the first place we can see that this is actually working out would be here. So it would be here and here, right? So we'll find the values of X for which that exists. Now, that would be, let's look at where that is. Where is F always above G in these? The X values for that would be all these X values that we have here. And it starts off where? It starts off here after this intersection. If you move to the left, you see that F starts to go above G. So where exactly, what X value belongs to this starting point? It would be 0. So after 0, when we move to the left, F is constantly above G. So we're going to write that down. That's actually where X is what than 0. It's moving to the left. Left numbers are numbers that are less than 0. So that's what we're going to write there. If we know now that, it means that X is less than 0. Okay, so we're not really done yet. We need to still use our vertical line / ruler. Hold this. And when we keep moving here, you see that G is above F. That's not what we want. We want where F is greater than G. Keep moving, still above, still above, still above, not working here. Then here, now your F is above G. Okay, so all the way here, G was above F. So now we have F being above G here, and it keeps being above G as they shoot till infinity. So what we're going to say is, where does that start? That starts, you see that just here, G was above F. So it starts here at 3. So since we know it starts at 3, we're just going to go ahead and say, okay, fine. It starts here and it's working for all these values. What are the X values that belong to this? Everything after 3 moving to the right-hand side. So that's where X is what than 3? Greater than 3. Okay, it's moving to that side. So that would be our answer there. So it's either where X is less than 0 or where X is greater than 3. And we don't need to say greater or equal to in any of these cases because they specifically just want where it's greater than G of X, not greater or equal to G of X. Okay, so that's our answer for 6.2. Moving on to the next question. Okay, then 6.5 says, determine the maximum vertical distance between H and G if H of X is equal to negative F of X for where X is an element of -2 to 3. Okay, so they want us to find the maximum vertical distance, a maximum kind of question, between H and G. So because they say between H and G and they say H first, we can just assume that they want us to find this distance by taking the graph of H of X and subtracting it by G of X, okay? Because you're trying to find the distance. These are graphs. However they look on a Cartesian plane, even if they were straight line graphs like that and that, which is not possible, but it's just an example. If that was the case, because they're saying the distance between them, if you wanted to find the distance between two graphs, okay, you're going to have to say, let's say you had that point, okay, and then go vertically in line, and that's why it's a vertical distance, okay, to that point, and you would have to say that one minus that one. So that's what we're trying to do, find a distance, and so you have to subtract naturally. Because we're saying H first and then G, let's go ahead and find out what they said H is. They told us that H is negative F of X. Okay, so we know this is to find the distance, right? Then they tell us that H is equal to negative F of X. Let's just speak about what that means. You see, if they say negative F of X, this is actually a reflection. So let's understand how reflections work. If you say this, take note of what became negative in F. Is it the X value that became negative or the Y value? It would be the Y value. Because remember that f of x stands for y, okay? If I said y is equal to x plus 2, and I said f of x is equal to x plus 2, if you graph it, it's going to be the same graph. So y stands for f of x. Okay, so we know that now. And so since y was made negative, this is how it's going to work. It's a reflection, right? But it's a reflection in a specific axis. We have two axes. We have an x-axis and we have a y-axis. If they make y negative, this is a reflection in the x-axis. Here's a brief explanation why, okay? It's a reflection in the x-axis. If I had a point and I called this point 1 and 2, right? And then I said, reflect this point across the x-axis. Like a mirror, you're going to just expect that this point is just going to be reflected across that x-axis. So here's your x-axis. Your x-axis is now behaving like some sort of like a mirror, right? So if this is the point here, it's going to be here. So the coordinates of this point will now be, I'll call it the image of P. The coordinates of this point would be what? Think about it. Did the x value change? No, the x value is exactly the same, still 1. What actually changed? It was the y value. The y value would change from what it was, and it will actually just get multiplied by a -1. So it would be -2. And so that's what happens. Now do you see that when you reflect something in the x-axis, it causes your y values to change. In other words, it causes your y values to get multiplied by -1. Okay, so keep that in mind. So now we can even find out what this graph of h is going to look like in our diagram. So let me pull the graphs down so that we can draw it down, just so that we can have an idea of what it's going to look like. Okay, so this is our diagram. Our graph of f is this. H is a reflection of f in the x-axis. So what's going to happen is this graph, if you reflect it across the x-axis, all the y values will change. So it means this point over here, it's still going to have exactly the same x value, but its y value is now going to be here. And then this point over here, its y value is going to be here. And if you keep doing that, you will notice that your graph is going to do something like this and kind of do that. Okay, so let me just actually draw it properly because it's not supposed to intersect here. Let me draw it properly. So like this, that's what it's going to look like. Okay, so we're going to go ahead, and that is h. Now there's a reason I'm drawing this. It's actually going to come into, there will be a reason. Okay, it has a need really. Okay, so now we know this is the graph of h. Let's go ahead and actually expand it, that equation of h. Let's go ahead and find out what it's going to be. Since we know it's h of x is equal to negative f of x, it just means whatever f of x is, you put negative in front of it. So I'm going to input f of x equation, which was x squared minus 2x minus 3. And so when you distribute in, you're going to get negative x squared plus 2x plus 3. That is the equation of h. And we also know what it looks like as well. So back to the question. Now that we have some things figured out, the question said determine the maximum vertical distance. We now understand you have to find maximum vertical distance by subtracting h from g, since they said between h and g. We know what the graph of h looks like. We also have the graph of g already completed. But then they say, after this, they say for where x is an element of -2 to 3. So what does that mean? Well, they're just saying you need to find the maximum vertical distance, but that distance is going to lie within the range or the domain of where x is going from -2 to 3. So we already know that this is -1 that we found here. So it's going to be between the points, the x values of -2 all the way to 3. It's somewhere within there. But there's a way we will know how to find it because they specifically asked for the maximum vertical distance. So let's go ahead and start finding the distance first. Okay, so let me put down the graph of G, which we already have. The graph of G was this. Let me put that down. So our vertical distance, we're going to find that by saying, I probably need some space here. We're going to find that by saying our graph of h minus our graph of g. So that is our negative x squared plus 2x plus 3 minus, now you see that you're subtracting by g and g has two terms, so you need to protect it with brackets. So minus x minus 3. So our vertical distance, not maximum yet, just the vertical distance. So our vertical distance, not maximum yet, just the vertical distance, is negative x squared plus 2x plus 3. Then you distribute here minus x, and that becomes a plus 3. Okay, so distance is just negative x squared, and we have 2x minus x, which gives you positive x, and positive 3 plus 3, which gives you positive 6. So this is what we have. Do you see that the distance, right, of h minus g is expressed as a parabola? They want you to find the maximum vertical distance of that. Because we were able to subtract those graphs and they gave us a parabola, right, and specifically a concave down parabola, the only way to find the biggest vertical distance between those two graphs is by using this graph and actually finding out what its maximum value is. I know that sounds weird. It's like, how does that make sense? It's really just that you took that graph. It's kind of like you're taking h, you're minusing it by g, and we're looking for the biggest space, the biggest distance between these. Now, mathematically, it formed a parabola, which is very helpful. If we just find the maximum value of this parabola, that will tell us the maximum vertical distance. It will tell us the line that is actually the longest when you take that minus that. Okay, so that's really what's going on there. So in order to find that maximum, you have to think about, how do you find the maximum of a graph, of a parabola, a concave down parabola? The maximum of that is always going to be the y value of your turning point. Okay, and here's just a brief explanation. You're looking at a graph. This is the highest that this graph can reach because it's concave down. The lowest it can reach would be infinity because it's going down forever. But the highest it will ever reach would be that y value. Okay, so there, we can go ahead and find that. So how do we find that y value of the turning point? Well, you have to find the x value first. And the only way to find the x value of the turning point is by using this equation, because this is in standard form. It's not in turning point form. So you say, first of all, x is equal to negative b over 2a. And that will give you the x value of your turning point. So x is equal to, we have negative, and then we have 1 as our b value over 2 times negative 1. Okay, so that's really just becomes positive. X is equal to a half. Okay, and here's the special thing about it. You see that? A half, and look at the hint they gave us. This was a hint. That's all this is. They told us that x is an element of negative 2 to 3. Meaning your x value, right? The x value you're going to substitute into your equation to find your maximum vertical distance. That number is going to range between negative 2 to 3. And a half really does. It is between negative 2 to 3. So we're going to take that half to find that maximum vertical distance. We're going to go ahead and take it and substitute it into our equation. Because a half right now is just the x value at which this parabola will be at a maximum. So now we find the distance itself. So the distance, I'll say d max, distance of the maximum. So we have negative, and then we substitute a half squared plus a half plus 6. And you just find the answer to this, and that would be your maximum vertical distance. And for that, we get 25 over 4. That would be the maximum vertical distance. I apologize for the long explanation, grade 12s. I'm just really trying to make sure that you do understand the topic. I don't want to just go through it and then say, okay, that's the answer, okay? But please do let me know if the explanations are long, then I'll try my best to shorten it. So that is our maximum vertical distance, and we move on to the last question of question 6. Okay, 6.6 says, given k of x is equal to g of x minus n, determine n if k is a tangent to f. We need the graph. So I'm going to get the graph first, and let's go ahead and look at what this means. Okay, our graph is here. So they say given k of x, this is a new equation, new graph they're introducing. Given k of x is equal to g of x minus n. So we have a straight line graph, because remember that g of x was already a straight line. That was the equation x minus 3, right? I just want to make sure that I have that down. So k of x is really just equal to x minus 3 minus n. So given that n is a constant, a positive constant, it would mean that you're just taking that graph of g and you're just pulling it down. That's all, right? So given that that is the case, they want you to determine the value of n if k is a tangent to f. So since we have k being g of x minus n, they have the exact same gradients. So it's really like k comes from g. If let's just say that this was k, we just have a straight line like that, and that is k. So since we have that this graph is moving down, they want us to tell them the value of n for which this graph is going to be a tangent to f, meaning it must only pass n at one point. Okay, so all we have about this graph k is that its equation kind of looks like this. K of x is equal to g of x minus n, which is of course x minus 3 minus n. So it has the same gradient as this. We need to find now the value of n for which this graph is going to be a tangent to f. So first and foremost, for it to even be a tangent to f, it needs to touch f once. Okay, so how do we actually prove that this is going to be a tangent to the graph of f? First of all, we can start with the fact that this line, this graph of k, is parallel to g. And since they are parallel, we know that they share the same gradient. So if the gradient of g is 1, then the gradient of k must also be 1. So why don't we just find the place on f, the point on f, where it has a gradient of 1? Okay, because since this is a line, its gradient is the same everywhere. Here, the gradient is 1. Here, the gradient is 1. But that's not the same thing for f. The f graph has different gradients. It has a different gradient here than here and then here. So we just have to specifically find out where the gradient of f would be equal to 1, because that would be here, since that is the only place that intersects with f. So that's what we're going to do. We're going to go ahead and find out where is the gradient of f1. So start off by writing down your graph of f. F is just f of x is equal to x squared minus 2x minus 3. So we want to find out where the gradients are both 1, where the gradients are the same. So how I'm going to do that is I'm going to take the graph of f and find its gradient first. The way to find the gradient of f is to derive it. So f prime of x is equal to, you say the coefficient times the exponent, which is 2, then you leave x, and then you subtract 1 from the exponent, which is 1, and we don't have to write that. Then again, negative 2 times the exponent of 1 is negative 2. You have x to the power of 1, and you subtract 1 from that, which gives you 0. Anything to the power of 0 is 1. Negative 2 times 1 is negative 2. So this is what we have. This is the gradient of f. Remember, we're trying to find out where is the gradient of f exactly the same as the gradient of g. Well, we know the gradient of g. The gradient of g is 1, because it's x minus 3 minus n. So why don't we just equate their gradients, because we know they need to be the same thing. They both need to be 1. So we're going to therefore say that the gradient of f, which is 2x minus 2, we should make it equal to the gradient of g, which is 1. Okay, so 2x is equal to, we leave 1 there, take the negative 2 over, it becomes a positive 2. 1 plus 2 is 3. And then divide both sides by 2. X is equal to 3 over 2. So this is the x value for which their gradients would be exactly the same. Okay, now we can go ahead and find the y value. Why are we going to find the y value? Because it's ultimately going to help us to find n. Since we will have the full equation and only one thing missing, we can just go ahead and substitute that point, the only points we know about k, the only point on k that we have, and it will help us to find n. So let's go ahead and find the y value of this point. Remember, the y value of this point, sure, it lies on k, but it also lies on f. So we can find its y value by substituting 3 over 2 as the x value into the original equation of f. It will give us the y value. So we're going to say f of 3 over 2 and substitute that into the equation. Okay, so this is what we have. And then on the calculator, what do we get? Our answer there is negative. We have 15 over 4. Okay, so that's our answer. Negative 15 over 4 is our y value. So I'm going to put that there. Okay, so negative 15 over 4. So now we can use this point because we know the only way that this can be a tangent to this graph is if this is the point, okay, of intersection between the graph of f and the graph of k. So we're going to take our equation of k and substitute this point into that because we're saying that this is really a point on k. Okay, so we found that, and now we can just go ahead and say k of x is equal to x minus 3 minus n, and substitute this point in as our x and our y value. So that is, the y value is negative 15 over 4 is equal to, and then our x value is 3 over 2 minus 3 minus n. Okay, let's just be careful here. So we have negative 15 over 4, and these two can subtract. So just subtract them. 3 over 2 minus 3 gives us, well, that is just 6 over 2. Negative 6 over 2 is negative 3. So 3 over 2 minus that. 3 minus 6 is negative 3. And then 2 stays the same because we're subtracting by equivalent fractions. You can also use a calculator. Then you have minus n. And then we can just take that, well, we'll just take the n over since it's negative. So positive n is equal to, and you have your negative 3 over 2, and that becomes a positive 15 over 4 when it comes over. Okay, we can change that. You can use a calculator as well. I'm just going to say times 2 to make the denominators the same. N is equal to negative 6 plus 15 over 4. Okay, and 15 minus 6 is 9. So our answer for n is 9 over 4. You can use a calculator. Okay, so that is the explanation of that. That's the value of n for which k would be a tangent to f. Again, the memo has not come out yet, but if you do see mistakes, please do point it out in the comment section, and I'll find a way to see what I can do about that if I must edit it later on. So that is the end of question 6. And then we move on to question 7, which would be in a separate video.